Okay, so for this presentation, I'm going to be talking about the decimation cipher. So a little bit of history about the cipher is that it was used during World War I from 1939 to 1940, and it was more widely used to deliver like field and scouting and emergency messages if the more complex systems were down. And they really tried to avoid using it too much due to the weakness of it, so ever since it was a thing, it was basically outdated. So this is Carl Friedrich Gauss, and he's the one who systemized the modular arithmetic. So without that, we would have no ciphers. So Carl did not invent the decimation cipher, but his work made it possible for others to discover it. So the cipher wasn't necessarily invented by a certain person, but more by like many mathematicians, and it really is relatable to the affine cipher. So many turned it to a different version of that to try and make it more complicated. So before we can encrypt and decrypt the cipher, we need to know what it is. So first off, it's a monoalphabetic substitution. So this means that you multiply each letter's number of the alphabet. For example, D is the third letter with A starting at 0, B would be 1, and so on, by a fixed constant mod 26. So you use 26 because there's 26 letters in the alphabet. And for the key, you can choose whatever you want, but there is 12 possible ones, and you need to make sure it's not a multiple of 26. So 2 and 13 are ones that you can't use. This cipher is very relatable to the Caesar cipher, so instead of adding, you just multiply. So for the encryption, the formula is E times X equals A times X mod 26. So EX is the cipher letter, X is the letter's number, and A is the key you multiply. So for example, I chose the word hello, which in the decimation cipher, it's Judd's. So H is the 7th letter in the alphabet. So my key that I chose is 5. So then I would take 7 times 5 is 35. And then I would take 35 divided the 26 letters in the alphabet equals 1 remainder 9. But we don't need to worry about the 1, so we only keep the remainder 9. And so then you start at A again, being 0, and count up the alphabet till the 9th letter, which you get J. So that's how H is equivalent to J. For the decryption, the formula is D times Y equals A to the power of -1 times Y mod 26. So dy is the decrypted number, Y is the value of the encrypted letter, and A to the power of -1 is the modular inverse. So for example, instead of going from hello to Judd's, it would be how you get Judd's to the actual word. So since we know J is the 9th letter, we'd go 5K equals 1 mod 26 because there's 26 letters in the alphabet and each letter goes up once. So then that we'd have 5 times 21 equals 105 equals 1 mod 26. So we get our 21 because we just plug in every number from 0 to 26 until we get it to equal the 1 mod 26. So then we take A to the power of -1, which is 21. So then J is the 9th letter, so 21 times 9 equals 189. And so then 189 divided by 26 is 7. So then you start at the beginning of the alphabet again with A starting at 0 and count to the 7th letter in the alphabet. So for code breaking efforts, you want to try all 12 decrypts until you find the right one. And then you also want to pay attention to letter patterns due to the structure. And you want to make sure you pay attention to patterns because you don't want to keep trying more and more ciphers just to get like a certain letter in it if it's like the third letter. But if you have the first two, then you should know pretty well that that's the key that you use. So if you know one word, solve for the other letters. So these are my citations that I used for my slide, and that's a little bit about the decimation cipher.